Now we're going to look at average rates of change again, but now in the context of applications. So we're going to first look at, in an applied problem, what the units are of an average rate of change and what the average rate of change means in the context of that particular function. Then we're going to use the average rate of change to make predictions about a function. So let's think about our work with velocity in the in-class activities. So in that case, t was time that was elapsed in seconds, and the distance was d of t, that's the distance traveled in feet at time equals t. Then if we wanted to find the average rate of change between t equals a and t equals b, well, what we did was we found the distance traveled in between time equals a and time equals b, that was d of b minus d of a, and then we'd find the time between time equals a and time equals b, and that was b minus a. So again, d of b minus d of a, that was the distance traveled between time equals a and time equals b, and then b minus a was the time elapsed between time equals a and time equals b. And then our average rate of change could be interpreted as the average velocity between time equals a and time equals b. And the units, of course, for velocity are feet per second, right? The distance was in feet, the time was in seconds, so our velocity is given in feet per second. And if we want to abbreviate that, feet, that's another way of writing feet per second. So in general, average rate of change tells us how fast the outputs change compared to how fast the inputs change. So if we want to think about what the units in general of what an average rate of change is, well, it's helpful to think about velocity. So remember, velocity, our outputs were distance, our inputs were time, and our units in velocity were in feet per second. So if you think what the feet means in that feet per second, well, for velocity, that feet was the units of the outputs of the function. The outputs of the function was given in distance. Distance is in feet. Feet were our units in the feet per second. That was the units of d of t. And if we want to think about what the second means in feet per second, well, the seconds were the units of our input of our function. The t was given in seconds. So that was the units of t. So if we want to think about what the average rate of change is going to be generally, it's going to work exactly like velocity, except instead of feet, we're going to have the units of the outputs, and instead of seconds, we're going to have the units of inputs. So our units of our average rate of change is units of outputs per units of inputs. So as an example, let's think about the savings example that we were kind of thinking about in the last video. So let's think of JoJo as keeping track of their savings daily, starting at the beginning of the month. So 7 days into the month, their savings is at $500. And then 19 days into the month, their savings is $800. And then let's think about what the average rate of change is going to look like in this particular example. So we're going to call the function s. It doesn't have a name in the statement of the problem, but we're going to give it a name s. So s of t is going to be the amount of savings that JoJo has after t days. So between days 17 and days 19, in other words, t equals 7 and t equals 19, a couple things are going to happen. First of all, the savings is going to change from s of 7 to s of 19. So when we find the change in savings, we're going to take the ending savings, which is s of 19, subtract the beginning savings, which is s of 7. Now let's see, 19 days into the month, it was $800. 7 days into the month, it was $500. So that gives us 800 minus 500, which is $300. That's our change in savings. Our change in time, well, that's just 19 minus 7. 19 was the end time, 7 was the beginning time, and that gives us 12 days. And so our average rate of change is going to be s of 19 minus s of 7 over 19 minus 7. That was 300 over 12. We computed those above, and that gives us 25. And then our units is, remember, it's units of the output per the units of the input. The output being dollars and the inputs being in days. So $25 per day. So let's think about what this means in terms of what's actually happening to JoJo's savings. It doesn't tell us what happens every single day of JoJo's savings, but it tells us on average what's happening in between those days. In other words, JoJo saves an additional $25 each day between day 7 and day 19 on average, which means that it's possible that some days JoJo saves a little more than 25, some days JoJo may save a little less than 25, but it all evens out on average to $25 each day of additional savings. So here's a question that we might want to ask. How much savings will we expect JoJo to have on day 30 of the month? And let's see how our rate of change is actually going to help us solve this problem. Well, again, we cannot say for sure what's going to happen in the future, but if we use what has happened between day 7 and day 19 to help us predict that, we can make a reasonable guess. So if JoJo continues saving at the same rate after day 19 as JoJo did between days 7 and 19, first of all, note that JoJo has $800 on day 19. There are 11 more days to get to day 30, so that's how many more days that JoJo has to save money. And we're assuming that JoJo is going to save on average $25 each day, so the average rate of change is $25 per day. So that means after 11 more days, that's 11 times 25, which is $275 of additional savings on top of what JoJo had on day 19. So the total is going to be the $800 that JoJo had on day 19, plus the $275 we expect JoJo to save in the next 11 days to give us $1,075 in savings. So that's one way of solving this problem. Before I let you go, I actually want to show you one more way of solving this problem, just in case this way makes a little more sense to you. So another way of thinking about this is the average rate of change of savings for JoJo we expect throughout the entire month to be $25 a day. Again, we can't say for sure, but that's our best guess. We can also compute the average rate of change between days and 19 using the formula for average rate of change. So we can say that our average rate of change is S of 30 minus S of 19 over 30 minus 19. That's just the formula for average rate of change. And one thing I want to note, based on the question, we want to know how much savings JoJo is going to have on day 30. Day 30, JoJo is going to have S of $30. So that S of 30 in that fraction, that is the quantity that we're looking for. That's the quantity that we want to solve for. The good news is we know what all the other quantities are. We know that after 19 days, JoJo has $800, so S of 19 is 800. And we know 30 minus 19, that's 11. Now, we're going to assume that the average rate of change of $25 a day is the same as the average rate of change that JoJo has between days 19 and 30. So that S of 30 minus 800 over 11, which is our average rate of change between days 19 and 30, is going to be equal to 25, which is our average rate of change throughout the whole month. And then it's just a matter of solving for S of 30. Remember, S of 30 is the quantity that we actually want to find. So now it's just a bunch of algebra. So if we multiply both sides by 11 to clear out that fraction, we get S of 30 minus 800 on the left-hand side, because the 11 cancels. When we multiply the 11 on the right-hand side, we get 25 times 11. Now, if we want to solve for S of 30, we just have to add 800 to both sides. So we get S of 30 equals 25 times 11 plus 800, which, by the way, should look kind of familiar from the previous computations that we did, and again gives us $1,075. So now that you've seen how these problems are worked, I think you're ready to work on the problems in average rate of change, the applications activities, and that's on the PDF file included with this video.